right, what's up? Jay Mays here. We need to talk. It's been a while, it's been too long. But you and I need to talk about first this beard. Way more beard than I've ever had, but it kept me warm in a dog sled race. I mushed in the Upper Peninsula with Nature's Kennel. It was amazing. More on that in a future episode. Today is huge for us because we start launching an episode every single month. Every single second Saturday of every month, a new episode of Seared. The entire team has been working hard on making this happen. We are starting with space and lunar landings. There are so many space cliches I wanted to lead this episode with. Mandalorian, of course. The first moon landing, yeah, definitely. Astronaut ice cream, maybe. Star Trek. Who's better, Picard or Kirk? Endless possibilities, but I'm going to demonstrate great restraint, refrain from launching into any of those. Sorry for one, I really am. Today is about an awe-inspiring journey to the moon. This episode is one of my favorites. We visit Astrobotic, the company that's taking us back to the lunar surface. Moon deliveries, moon landers, moon rovers. Up next, enjoy. If you look around me, right here and here, you'll see the next lunar lander. It's called Peregrine, and it's going to carry rovers and other space robots. Peregrine was created by engineers at Astrobotic in Pittsburgh, Pennsylvania. These amazing humans are making the dream of moon landings possible once again. Standing here with the actual payloads, I was pumped. An entire suite of scientific instruments going to the surface of the moon, staged right next to me. Each specially crafted to measure a specific physical phenomenon, including a few built by NASA. What else is Peregrine taking to the moon? Deliveries. The engineers who dreamed up Peregrine have built a lander that can be filled to the gills with personal mementos, keepsakes, and messages from kids around the world. Maybe it's even carrying something from you. We'll all watch excitedly as Peregrine launches aboard the Vulcan Centaur, an awesome name for a rocket by the United Launch Alliance. And after a 35-day journey to the moon, Peregrine will autonomously map the terrain on its terrifying landing approach, ultimately gently touching down at just 2 miles per hour, live streaming data and video as it goes. Epic. I'm Jay Mays, and this is Seared, stories of hard work and remarkable people. Today, we're meeting a new friend, project manager at Astrobotic, JOCE MACKAY. JOCE is going to walk us through what it takes to pull off this mission. Flight plans, payloads, clean rooms, high bays. But before we are allowed to see the Peregrine payloads, first, we have to suit up. Out of an abundance of caution, we donned these bunny suits and dissipated and neutralized any potential electrostatic discharges. JOCE knows just about everything there is to know about the payloads for Peregrine. Oh, and thanks to Alivia for making this tour happen. She's awesome. Once suited up, we entered the high bay, a big clean room, where Peregrine payloads are staged before eventually being sent to Cape Canaveral for launch. All right.
Yeah.
Tell us what we have here.
Okay, so here we have about half of our payloads that we're going to have on mission.
Okay.
We have a variety of passive and static and active payloads. Mm-hmm. So one that I want to point out is MAG. Mm-hmm. And you can kind of see here the boom that will deploy. So you can see all of the different tubing that's kind of coiled up in here.
Yep.
So this will deploy out onto the lunar surface. And when it deploys out, it'll start being able to receive science from its little detector right here.
Yep.
We have a bunch of different payloads as well. So Moonarch right over here is a static and passive payload. It's actually a design project out of CMU, that's Carnegie Mellon University. And it is inspired by the moon and Earth and actually atmosphere too. So it has a ton of different aspects to it. We have LETS. This is another NASA payload that's active and will be doing science on the surface of the moon.
Awesome.
PITMIS, which is covered up right now because it has a special thermal coating very similar to LETS that is actually, if you touch it, it can flake off, but it's really thermally insulating. So it's a very unique special coating.
Does that have that special coating because of the type of instrumentation underneath it?
The way to keep your payload thermally in a safe zone is the best way to describe it.
Yeah.
There are different ways to do it. So you can use MLI, which is this shiny material on MAG, or this material over here.
Yeah.
Or you can use paint.
Sure.
And the paint that you can use, it's really sensitive to oils. So like hand oils will cause it to disintegrate and kind of fall apart. But it's really, really good to protect from solar radiation.
I see.
So that way your payload doesn't overheat.
Right. I see. So why is this one not covered with this material?
Just a slightly different kind of paint.
I see.
Yeah, so different compositions cause it to have different kind of properties. We do generally keep LETS covered with a bag, but it's not as fully enveloped as PITMIS is here.
PITMIS, gotcha. So we have LETS and PITMIS.
MAG, MOONARK, M-SOLO. M-SOLO is a big boy.
Yeah.
A mass spec looking for water. So it has a little opening down here, and that's where the mass spec will be looking down onto the lunar surface.
And that's mass spectrometer, right?
Mass spectrometer, thank you, yeah. And then we have NSS and NERVUS down here as well. And I think there's another payload here, but I'm not remembering which one that is right now.
Sure.
But a bunch of these payloads here all work together, and they are going on the next mission, Viper, up to the moon as well.
Gotcha.
So you'll have Viper with these additional payloads of M-SOLO, NSS, and NERVUS.
Is Viper mission 2?
Viper is mission 2 on Griffin. That's another lander of Astrobotics.
And these are going to be on the Peregrine lander?
These are on Peregrine, a much smaller lander.
Right.
Griffin has a lot larger fuel tanks, and that's because it's going to a different part of the moon.
I see.
So the South Pole. So it's a totally different orbit that you have to do, and like trajectory.
Right.
So it's a very different process altogether.
Are these landing with thrust, just direct thrust? There's no landing maneuvers like aero cranes or anything like that?
Yeah, just thrust.
Yeah, okay,
Unfortunately,
gotcha.
we don't have any cranes yet, but maybe one day.
Okay. When we see the model of this put together, it's going to be about how big, the Peregrine model?
Yeah, so these decks come up to about my eye height.
Okay.
It's not quite as big as this room that we have here. Oh no, I unclipped. I'm going to clip back in. That's to keep us electrostatically safe for our payloads here. So it's not quite the size of this room. It's a little bit smaller.
Okay.
But I mean, it's big.
That is good size.
Yeah, it looks strong, and I like to say chunky,
Yeah,
right? Because it's
I
like
like
a big,
chunky.
it's like a big lander, but about the size of a car.
Are you working on Peregrine and Griffin at the same time, or is the focus really on Peregrine right now?
So it depends on my day.
Yeah.
I do Griffin work as well, but I'm predominantly Peregrine right now, especially as we get the payloads onto the decks. So we all wear different hats here at Astrobotic, as you have to, kind of in a startup, and as you're trying to go to space, it's really hard.
Sure.
So I'm a payload manager. I help get the interfaces appropriately kind of matched for payloads to our interfaces as well. And then I'm also a project manager. So I work on like thermal systems, propulsion systems, structure systems, so kind of across the board. And in that project management side, I work on Griffin as well as Peregrine.
Okay. So you have special considerations across the board here, whether it be avionics or navigation or thermal. You mentioned thermal earlier. There's a lot of thermal variation you're dealing with too.
Absolutely.
So are you guys developing the technologies or processes to thwart the thermal variation, the sun side and the black side? And
So yes and no.
Okay.
Luckily, that part of space is very well developed
I see.
already.
Yep.
So there are specialists out there who can help us with that.
Okay.
So for example, right, this deck here, it looks beautiful. I hate that we are covering it up, but we are covering it up with MLI. And that's a similar material to here that we see on M-SOLO, this silver part.
Okay, so where will that be? That'll be covered?
The entire deck will be covered.
The entire deck will be covered?
Yeah, so there will be holes for the payloads,
Yep.
right? So they could do their science, but the entire deck will be covered, and that's necessary for solar radiation. That can be a huge problem. There's also the lunar surface also reflects sunlight back up.
Oh, sure. It reflects it all the way back to us, in fact.
All the way back to us. And
Yeah.
it causes a huge problem where you can get like thermal hot zones if you don't have MLI, and that can cause the deck to heat up.
Off the moon. That's crazy.
Right?
I never considered that.
Yeah, it's crazy. All of the different aspects that you have to take into account because you're going to space and nobody's there, right? If something goes wrong, you don't have anybody who can be like, oh, let me go fix it real quick.
I think that's what's fundamentally different in the engineering of not only the lander itself and the rovers, but also these devices, is no one can go up and fix them or change them or tweak them. So when you're building the lander, it has to have the ability to reset itself. If you get like a bit flip or something like that, it has to, you have to be able to reset the software entirely. Yeah. Like all of that is a part of the consideration, right?
Yeah, absolutely. So that ties into our mission operations.
Okay.
So our mission ops team is fantastic and has already for months been like, we need to think about mitigations if something goes wrong. So like, what is our plan going forward? Because things go wrong, right? Like, for example, we'll have some thermocouples here on the deck to look at different deck temperatures and make sure everything's okay. Mm-hmm. If one of those breaks, they're very thin wires. Mm-hmm. If one of those breaks, well, what do we do? If we're getting a no read, what does that mean? Does that mean it's either an issue thermally, or does that mean that it's an issue with a thermocouple? Mm-hmm. How do we respond?
Right.
So everything like that we have to take into consideration, because nobody can go in and like push that wire back in and be like, it's fixed.
Right.
Yeah, it's a totally different problem than what you have here on Earth.
Long-term strategies, do they include like some sort of like fix-it AI, fix-it robot, like some sort of mission specialist that you can control from headquarters?
Yeah, so there's tons of different aspects there, I think, that are being worked. Sure. One is a drone.
Okay.
So they're working on prototypes for drones where you could fly in, right? So you could land somewhere else, fly to the other lander, and then try to like fix it, manipulate it in some way robotically.
Yeah.
There's also rovers, of course. So if you have something that's not high up, where you can send a rover in to either deliver power or another payload that could fix something. I know recently here in Pittsburgh, I used to work in energy, and there are this company doing like pipe crawlers.
Oh yeah,
is what they build. Which are super cool.
Yeah, they start out really small and then they kind of expand. And
exactly. So that technology is out there, and you could use that too to like crawl up a lander and fix part of it with robotics like that. So there's a ton of opportunity on the horizon.
Yeah, tons of opportunity.
Yeah.
So let's go back.
Not since the Apollo missions captured the world's attention 50 plus years ago has the United States been back to the moon. Apollo 11 delivered the first Earthlings to the lunar surface. During Apollo 15, Worden performed the first spacewalk in deep space. Scott and Irwin drove around the surface of the moon in the first lunar rover. And the last time anyone was on the surface of the moon was December 7th, 1972, the Apollo 17 mission. This mission carried Harrison Jack Schmitt. Astronaut, yeah, of course, but he was also a university professor. What I like about Apollo 11, 15, and 17 is that they represent what going to the moon is all about. The evolution of exploration. From doing what was thought to be impossible, to constantly pushing boundaries, to getting down to scientific business, 11, 15, and 17 represent the arc of scientific work that is critical to the expansion of knowledge and crucial to humanity's understanding of how to travel the cosmos. Simply put, what NASA and Astrobotic are doing is enabling further exploration. That's just mind-bogglingly awesome.
Yeah.
So let's go back to what's being delivered to the moon on Mission One.
Yeah.
I think one of the critical points is, if you think of returning to the moon and returning to the moon's surface and doing that, launching from U.S. soil, this is the first mission in 50 years.
Yeah, since Apollo.
Since Apollo, yeah. Where, we're going to be doing that. And you guys are doing it next year.
Yeah, we're doing it next year, mid-2022.
Yeah.
Very exciting.
Super.
Yeah, so Apollo was 69, right? July 20th, 69, 1969. So exciting that was 50 years ago as of 2 years ago.
2 years
so
ago.
within 53 years, we'll be going back to the lunar surface.
And I think the last Apollo mission was 73-ish?
Might have been, yeah.
Somewhere in there?
Yeah.
Yeah, so, and we haven't been back to the moon since.
We have not.
With the lander, yeah.
And we will be going straight here out of Pittsburgh. We'll be sending a lander to the moon. It's such a unique and special experience.
Yeah.
I'm honored to be a part of it, honestly. But yeah, I think it has the capability to inspire so many different kinds of people. I mean, we hear from people of all generations. So we actually have part of a payload from one of the astronauts who was in the Apollo missions.
Oh, that's so cool.
Right? And it means so much to him and to his wife to send this back to the moon where he was.
Yeah.
So when you hear stories like that of the older generation who's been there and who know and are so excited for us to be going, and then inspiring the younger generation too, saying, hey, you can do this. This is possible if you work hard and you look towards whatever curiosity is out there for you, you can do this.
Do you have a singular point of space inspiration that you recall? Like, was there something you saw that you were like, I gotta go do that?
Yeah, so I was 5, and my mom took us to Kennedy Space Center in Florida. Our grandparents lived there, so she was just kind of like, this will keep them busy for the day, sure. I have 3 other siblings. None of them had the same reaction that I did.
No kidding.
But I saw, I just saw like the space shuttle and kind of lost my mind. And I was like, that's a thing that you can do?
Right. People
you can
ride
work on
that?
Yeah, you can ride that. You can build it.
Right.
And that inspired my love of space ever since. So I have a space charm bracelet that I got from that day. It's so tiny.
Whoa.
Yeah, but I still have it, and I wore it for my interview here. And I got that. Yeah, it was just like the legacy of kind of building
That's
it.
incredible. You brought that with you to the interview.
I did.
I think that was a good luck charm then.
I think so too.
So there's a lot of companies that have contributed to this, universities, vendors. You're really establishing a method for more researchers, more contributors to put payloads on the moon. You're building that process, right?
Yeah, so our goal is to make it accessible to everybody.
Yeah.
So a lot of different companies, it's like millions, tens of millions of dollars to get anything to the moon.
Right.
And we don't think that's fair or an accessible model for everybody, because space should be accessible.
Yeah, absolutely.
Yeah, so making it accessible to everybody, we have Moonbox, and it costs like $400 to send something up to the moon. And it could be anything that you want, which is so special. And all of these payloads here, right, we provide services to the lunar surface much cheaper than a lot of other companies can.
I mean, you're a private company, so you also have to do things in a way that is repeatable, efficient.
Absolutely.
You're going to be establishing a business model around the moon.
Yeah.
Deliveries to the moon.
Deliveries to the moon, yeah. And for all different kinds of science instruments, right? So I think that's another really cool part of it, is we don't only do one thing.
Yep.
You can come to us and say, hey, I would really like to send this thing that does this.
Right.
And we'll say, okay, let's figure out how to make it work. And we provide our engineers to you too, so you're not alone in the process.
Oh, that's incredible.
Right, like
You're
that's
offering
the
a
scariest
service in
part.
that way too.
Yeah, because it's scary.
Yeah.
And I think what's really unique, right, is you hop on the phone with myself or my coworker, John Walker, and you talk to us about, hey, here's what I want to do. Here's how I technically think I can do it. How can we make this work? And we're on the other side saying, okay, that can work. Okay, you can't do that because that's not really how like the physics of the lunar surface works. Okay, we can probably make that work. Let me go talk to some people.
Yeah.
And you figure out how to build something that's unique and special and does what you need it to do, but also gets to the surface safely.
So when I want to launch the Seared payload in the future, you're the one I talk to?
You're the one, that's me, right here.
That's you.
Yeah.
All right. Excellent. I like that.
I pick up the phone, we talk once every 2 weeks, at least.
Yeah, of course. So how many, we've seen a few of the payloads here. How many total payloads are being sent in Mission One?
21.
21.
And that doesn't include all of the different payloads that we have in Moonbox.
Okay.
So if you count all of that, that's about 100,000 people.
Whoa.
Yeah.
Whoa.
Yeah.
That's incredible.
Yeah, so we have payloads here that have touched everybody from across the globe. So
international companies are also bringing their
International
like some of the
companies?
big payloads here, right?
Yeah. So here there aren't any on here quite yet.
Okay.
But we absolutely will have some. So those are from Japan and Mexico
Yeah.
and Hungary, Germany, and I think a few others as well that I'm probably forgetting.
Right.
But we will have those all on here, and some of them are deployables. So a catapult that deploys out little rovers, which is cool.
That's so awesome.
Others that are deploying onto the surface of the moon. And we have a rover as well coming out of Carnegie Mellon University, who's here in Pittsburgh too, and they'll be deploying onto the surface.
So these aren't launching back off the moon. These are going to the moon and staying permanently, right?
Staying forever,
In
yeah.
perpetuity.
Until an astronaut finds them and wants to take it back home with them, right? But yeah, we'll be here on the surface of the moon. A lot of these are acting as time capsules. So
Yeah.
Moonarch specifically
Yeah.
is a design project aimed to kind of show what is the human experience in 2022
Yeah.
and 2021. Like, what is it right now? Capture
Yeah.
that. And that way, if an astronaut finds it in a few hundred years, they
Yeah.
can say, whoa, this was so different from what we experience on Earth now.
Right. Yeah, the human experience in 2020 and 2021 has been quite unique. Maybe not unique. Interesting, I guess.
Different.
Different,
I think
yeah.
different. Yeah.
Yeah.
Yeah. Pandemic changes things.
The pandemic changed a lot of things.
Mm-hmm.
This is all pretty awesome. In the rest of, what do you call this clean room? Is this a bay, high bay?
High bay clean room
High
is what
bay
we
clean
call
room,
the clean
okay.
room. I like to call this area here a zone of safety.
Zone of safety.
Yeah, it's just another reminder to people that, hey, this is really, really important hardware.
Right.
Do not come in here unless you are authorized to do so.
Because this is millions of dollars worth of equipment here.
Yeah, each of these payloads that are on here is worth millions of dollars.
That's
Right.
incredible.
And then when you think about the decks, like these are specially designed by our
Right.
structures team here.
Right.
Oh no, the light.
That happened
Yeah.
to us?
There we go. Perfect. Thank you.
Yep.
Yeah, so our deck here is also specially designed by our structures team, which
Yeah.
takes tons of hours of man effort, as well as, having to get this machined specialized by different shops.
Perfect. Yeah.
Yeah, we're talking thousands of dollars.
I assume the process from design to launch is fairly iterative along the way. You know, you're starting with a concept that is kind of nebulous and working that down and then iterating on it.
Yeah, absolutely. I think for the payload specifically here that we're looking at, the process to design a payload takes years before a mission is ever booked.
Right.
So you have things on these payloads like adapter plates. So we look here on MAG and we see the adapter plate.
Yep.
And that is added after you start designing the payload itself.
Sure.
Because it has to adapt to our deck.
Right.
Which is something that it didn't initially plan for. So it's always a kind of a different process, and you go back and forth through the design process to make sure you have something that works really well for everybody. Yeah.
Who are you riding to space? Like, who's the launch vehicle?
Yeah, so we're riding on ULA's Vulcan.
Yeah.
First of its kind rocket, which I know everybody gets so scared about
Yeah.
because we've seen a lot of those explode.
Yeah.
We're not nervous with ULA.
Yeah.
They've been a fantastic launch provider, and they have always had successes. They've never had a failure.
Yeah.
So one of those things that we're not worried about. We're very, very excited to be going up.
The Vulcan rocket is the Atlas V iterated on, right? That's
Absolutely.
the next version beyond the. Okay.
Yeah. So upgraded, better,
Yeah.
more exciting.
Better in every way.
Yeah, exactly. We're so excited to be in their payload fairing. So
Yeah.
we'll be in there, and then Centaur breaks off, and then we kind of come out into space.
That's actually a question I want to ask. Are you handling basically from fairing deploy, and then your payload takes off for the moon, and then it's all your control, right? There's nothing else that ULA does at that point.
Nope. Yeah. So
Okay.
ULA gets us up into space,
Yep.
and that's it.
That's it.
Then they're off.
And then that's Mission 1, mid-2022. Mission 2 is SpaceX, right?
It's SpaceX. Mission 2 is Griffin carrying Viper, NASA's Viper payload.
Which is a huge deal.
Huge deal.
Yeah.
Yeah. And on Viper, right, we have a couple of payloads that we're going to see here again on Viper. So M-Solo, NSS, and Nervous.
Yep.
So Viper's going to go onto Griffin, which is a much bigger model than Peregrine, and that will be going on to the Falcon Heavy.
Yeah.
Which
That
is
would be
really
awesome.
exciting.
Yeah.
Yeah, for SpaceX. So we'll be heading up there because Griffin is a much bigger model.
Yeah.
And they need a bigger rocket.
If all this sounds new, that's because it is. Not only will Peregrine Mission One be the United States' first trip back to the lunar surface in 50 years, We are talking the Apollo era of spaceflight here. It will be the first commercial mission to land on the moon, or another planetary body for that matter, ever.
In the future, Mission 3, Mission 4, Mission 5, do you focus on one lander, or is it specific to whatever you're bringing up? You might do Peregrine, you might do Griffin, you might do something else.
Yeah, so to make space accessible, and I think we're seeing this across commercial companies right now, you have to get into like a specific lander design.
Right.
So you can't keep redesigning landers because it's a really expensive process.
It's got to be repeatable.
It's got to be repeatable in order to be efficient and also cost effective for the customer.
Sure.
So I think within our next few landers, we're going to land on a much more unique to Astrobotic design.
Yeah.
And once we have that design a little bit more solidified, then it'll be a lot cheaper going forward.
And that's not to say that you'll never iterate on that design.
No,
it's just you're structuring it in such a way that you're foundationally sound, and then you can improve upon that in small ways, while also in parallel developing something brand new.
Exactly. I mean, when you think about the space shuttle, right, there was a design for the space shuttle.
Right.
And there's a reason why they made so many of them.
Yeah.
Because it's an effective design and it works, and you can make it more at scale if you have a set design.
Right.
If you constantly have to change that, you have to find new vendors, you have to find new manufacturers, you have to find new ways to do things that are similar to what you were doing.
Yeah, new specs, new dependencies, all the way down.
All the way down. New testing modules. Yeah.
Yeah.
Tons of different things that you have to consider. So it makes more sense to have a couple of set designs.
Yeah.
And you build from there.
I think it's really special what you guys are doing. I just think the notion of some kid, who's sitting in his class in first grade thinking, I want to send this thing in my hand to the moon. They can literally, they're very close to being able to just do that.
They can do that.
They can do
Somebody,
that.
Yeah, we have, so Astro Liz, I don't know if you've heard of her. She's, she's
Liz.
Fantastic.
Yeah.
Great young
I shouldn't
scientist.
say I know Astro Liz. I know of Astro Liz.
Oh, but I mean, she's, she's cool, and we love her here, and she's sending a sticker up to the moon in Moonbox.
That's awesome.
Yeah.
Kids can do that now.
Kids can do that.
How inspirational.
I know, right? And you look up to the moon, for the rest of your life, and you say, I have something.
Yeah, that's true.
There.
I didn't even think of that. Yeah, it's there for the rest of your life. You can always look up and see that thing.
Yeah. Which is very, I don't know, I think special, and it inspires a different level of curiosity than I think what we've been able to do prior.
And I think it just changes the thinking of everyone who grows up in an environment where you can send something to the moon anytime.
Yeah.
It's that box is checked for them. They can just assume that. So where their mind goes after that, I mean, brand new doors.
Right. Where are you going to go? Mars?
Yeah.
Saturn?
Yeah, that's so. The moon is an airless body. Landing in an airless body is obviously a lot different than landing somewhere with an atmosphere. Yep. Are you going to be targeting other airless bodies for these landers?
So right now our focus is absolutely the moon.
Focus on the moon.
We want to get to the moon first. After that, we are a space robotics company, so we are going to be looking outside of the moon and just lunar surfaces. But we are the moon company right now.
Yeah.
We send things to the moon.
When you send things to outer space, you can't service them. No tune-ups, no wipe-downs, nothing. And a single particle of dust can disrupt a vital circuit. So to decrease the chance of a malfunction and increase the longevity of their equipment, Astrobotic is serious about cleanliness. Gloves, clean suits, the works. After we doffed our bunny suits, Joss and I sat down for a little bit of Q&A. We moved on from payloads to space travel, mission details, the landing, and more. Watch this.
So why go back to the moon? Like, why should we as a society even think about going to the moon?
So, I mean, it's in our backyard,
Yeah.
right? We haven't been there in 50 years. Why not is really the question. So we keep expanding our envelope to Mars, Venus, go explore further and further, Saturn.
Yeah.
And that's great. But if we can't land in our backyard, I think we need to work on that technology a little bit more and make sure that we feel really safe there.
Sure.
And also, it just creates this like curiosity and inspiration, I think, for younger generations.
Yeah.
Where you can go somewhere so close and send something to the moon so close that maybe wouldn't be feasible for another mission for, dozens, maybe 100 years.
Yeah.
But we can do this now.
We can do the moon now.
Yes.
Is it technology-wise? Is it a stepping stone to other airless bodies like we talked about previously?
Yeah, I think so.
Yeah.
Absolutely. I mean, right, the technology needs to develop, and we're really different from where we were when we were developing Apollo in the 60s and 70s to where we are now, what we're capable of doing,
Right.
which is why we're able to take payloads and other different kinds of technologies that are being invented and take those up to the moon with us. And it will progress even further, right? To drones, to further rovers,
Yeah.
and a lot of other exciting technology. But where we're starting right now is getting us to the moon and getting rovers out there to explore.
So what we saw were the Peregrine payloads, what we saw in the lab. How are the Griffin payloads different?
So completely different.
Right.
On Peregrine, we have 21 different payloads going up to the moon. And these are all from different companies, different entities, some commercial, some private. But on Griffin, it's one big payload called Viper, which is a rover that's going to go out down the ramps of Griffin and go explore the lunar South Pole.
Astrobotic designed the the landers themselves, plus all the ramps and everything else needed to get the rovers onto the moon, correct?
Yeah, absolutely. So all of our designs are in-house, which
Yeah.
is crazy when you think our design team isn't huge, right? It's not hundreds of people. Our entire company is 150 people of just honestly brilliant engineers. So when you think a small subset of that designed these lunar landers, the actual structure of it, and made something that's going to go straight up to the moon, I mean, it's incredible. It's a couple of people, really.
Right.
Yeah.
A few people that have their hands on this.
Yeah.
So after separation from the launch vehicle, you guys take control of the entire mission from there, all the way to the surface.
We do.
It goes right through your mission control system. What are you burning to get there?
So it's a combination of MON25 and MMH. These two chemicals, when you put them together, create crazy thrust.
Right.
It's an explosive reaction. So we use that in our engine system in a very, very special mixing ratio, and that propels us to the moon.
Got it. Do you burn up 100% of it all the way to, nearly 100% of it all the way to landing? There's probably a margin of error in there.
There's a margin of error, of course. And certainly for the descent, you have fuel left over, because if
Right.
you didn't, you wouldn't have a landing, you'd have a crater.
Right.
So yeah, you have a certain percentage left over. I'm not a propulsion engineer, so I don't know exactly what percentage,
Sure.
but certainly more than enough with a margin of error to get us safely to the surface of the moon.
Got it. So one area we didn't talk about in the lab is the actual landing,
Yeah.
which is just, it's got to be crazy scary.
So landing, when you look at it, like if you were standing in the room,
Yep.
right, what you're gonna see is a bunch of frozen people,
Right.
because our entire landing system is autonomous.
Okay.
So once we hit the button that says, okay, go into descent, nobody touches anything.
Right.
So you're gonna have crazy quiet pin drop for 30 minutes until we land. And then once we land, it's gonna be like screaming and shouting and probably the loudest roar that Pittsburgh has ever heard, even with all the stadiums right here.
Right here, yeah.
Yeah.
We can see the stadiums from here.
Yeah, I mean, screaming. But we won't touch anything once we hit
Completely
into descent.
automated.
Yep, it's not on us.
When will you know for sure that everything went well?
So what you're gonna hear from a lot of different engineers is the word nominal. So in mission control, every single different subsystem will be checking out as we're getting data back from our lander. And if you keep hearing the word nominal, 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 yeah, you know you're fine. And then we'll get the green from probably mission ops,
Yep.
I think, to say, hey, we're safely on the ground in our systems team. And then it will just be like everybody stands up. Yeah, cheers, screams, probably crying, I imagine.
I would think so.
Yeah.
There's a lot of emotion. I think whenever you invest yourself into one project, you know, you're going to have a part of you in it, and that just brings the emotion to the front.
Yeah, our mechanical systems and fluids manager, Pete Fry, he has this goal that he'll be the last person to see the lunar lander ever until it's on the moon, right? So he's gonna pack up our baby into ULA's Vulcan.
Oh, wow.
And watch it
Yeah,
go.
watch it depart.
Yeah.
It's going to be amazing.
Yeah.
Are you going to have people on site at the launch location as well, I assume?
Yeah, so they'll be down there probably for about a month. if not longer, depending on weather, right? Which is a huge factor in launching that a lot of people forget about.
Sure.
So you may have a specific launch date, but if there's a thunderstorm that day, you're not launching.
Yeah.
So that's something that we really kind of have to play around with. So we'll plan to have people down there for a month, but it could extend out to 3 depending on what happens with weather, launch delays, other launches that are scheduled.
Right.
There's a lot of different factors.
In terms of landing zone, how small of an area have you chosen? And do you have multiple landing zones?
So it's not a small area. It's lactis mortis.
Okay.
We're specific, right? Like our GNC team knows the coordinates of where we're supposed to land.
Right.
And we don't want to land too far off because the moon is a really rocky surface.
Right.
And because of that, right, if you land the wrong way, you could land on the part of a crater or at a weird angle.
Sure.
And then it makes it really hard for our solar panels to work and get the kind of battery power that they need to make sure that all of our payloads can work the way that they need to. So it is specific. Don't get me wrong.
Right.
I can't tell you exactly how big the landing pad is.
Okay.
But it's enough margin.
Yeah.
I'll say that.
Enough margin. You can't tell us because you don't know or because it's like secretive?
I think it's kind of both.
Okay.
Yeah. So you have to, there are certain moon rules, which I didn't know. This is fascinating. So you have to be, from one landing site, you have to be 2 kilometers from another landing site.
I see.
Yeah. So if another nation landed 2 kilometers away, you have to be outside of that zone.
Okay.
So that plays into it.
Yeah.
Really interestingly.
Yeah.
Yeah. So if you have, like, in terms of setting up a moon base, which a lot of people talk about, you could set up moon bases that are 2 kilometers apart and just build this massive, like, network, basically, just on different landing zones.
Yeah.
And that's kind of the goal of some nations, some plans. For us, it's making sure that we are out of those keep out zones, but also in a safe area for us to land.
I see.
That's also scientifically significant.
That's what I was going to ask. You have different instruments in your payloads that are going to be doing scientific work, so you have to make sure it matches their goals as well.
Exactly. Yeah. So, you work kind of as a team with your payload, so you find out what science is important to them, and then with that, we figure out, okay, where can we land where that science makes sense?
Yeah.
And then, we come to a resolution.
After separation from the launch vehicle, trajectory control completely on your mission control system. So you have trajectory control specialists that on your team.
Yeah.
And so they're receiving a data stream from your lander on approach, putting it into orbit over the moon, choosing the landing spot, or at least getting it close. Is there an autonomous component to sort of mapping the landscape as the lunar lander comes down and attempts to land in a good position?
So all of that is done ahead of time, and all of that is already built into the lander.
I see.
Yeah, so if it is coming in and it notices, hey, this looks really off nominal, there's of course software that says, okay, if we're off nominal here, we're gonna do this. We're gonna do Y or Z instead of the plan that we were on.
The lander will make an adjustment and...
If necessary.
So that means you've developed and tested that technology, or at least acquired that technology to map out surfaces on approach and then written the algorithms to manipulate that, right?
Yeah, our GNC team is incredible.
GNC stands for?
Gravitation, Guidance, Navigation, and Control. Thank you.
Okay.
So many gravity things here. Yeah, Guidance, Navigation, and Control.
Gotcha.
GNC.
Your team is referred to as, or called?
So we're the projects team, also the payloads team. Like I was saying earlier, we all wear a lot of different hats here. Yeah. So myself and also my coworker, John Walker, we work with our payloads, and it is fantastic getting to bring all these different teams in from all over the world to integrate them. We also work on projects, so that means that we're responsible for schedule and budget on the different teams kind of across our entire company here, just to make sure that we're on track. We have a good understanding of the scope that we need to be doing going forward, and that we're actually building the lander like in a reasonable time frame.
Right. With John, was he the one that was sitting next to us that we accidentally interrupted when I first met you?
Yeah, John Walker. Yep.
Okay, John. Okay. Sorry, John Walker.
Yeah, I know.
We were very disruptive at first. We talked a little bit about terrain-relevant navigation. Call it that. Are you using? Is that optical? Is that LiDAR? Like, what types of systems are in play there to map as the lander chooses a spot?
So my understanding is LiDAR.
Okay.
I know optically we have different sensors as well. So I would imagine a combination of both.
Yeah.
But I'm not positive.
Okay.
Yeah.
with we mentioned when we were talking previously in the clean room about all the different types of deployments. We talked about the catapult deployment. We talked about the extension deployment. What other types of deployments are going to be on Peregrine?
So on Peregrine, we have 3 main different types of deployment. So catapult is one where we're catapulting little rovers.
It's so fun.
Isn't it?
I picture like actually a little trebuchet for some reason.
That's essentially what it is.
Oh, very cool. Yeah.
Yeah. Just like literally onto the lunar surface, which is going to be really cool. And then we also have the MAG boom deployment, which will be deploying out onto the lunar surface, so extending out. And then we also have rovers who are deploying onto the surface. So they essentially drop down onto the surface. So they're attached at the bottom of our decks, and then like very smartly and in a very well engineered way, drop onto the lunar surface and drive away.
Are the mechanics behind the drops the same for everyone that's dropping down, or is it different based on the rover?
No, it's different based on the rover. So when people come to us and say, hey, we have a payload, we say, okay, here are do no harm requirements. So that means a do no harm requirement is something that we require to be to a certain standard so that it doesn't cause harm to either our spacecraft or other payloads.
Sure.
It's our number one concern. So we don't like pyros, for example, because they can explode and either harm us or harm like a neighbor payload.
Right.
But there are other options like frangibolts is something that is very commonly used in space, where a frangibolt essentially, like you apply a current to it and it breaks off. Yeah, and then you can drop off from there.
I see. What are the most creative ways you've been asked to get something on the surface from the lander? Has anyone like said, we need to do it this way? And you're like, I don't know about that.
Honestly, the catapult one is very new.
Yeah.
So no one has ever catapulted something into space before.
Oh, wow. So that's even a first.
This is a big first, which we're really excited about.
Are you catapulting just something that is going to then lay in stasis or static, or is it going to move around or whatever?
Yeah, so it catapults these little gears, are what they look like.
Yeah.
And they have little wheels on them.
Oh, okay.
Yeah, so they're cool. Honestly, they look like little wafers. And they catapult right onto the surface and then they drive around. They talk to each other. They're really cool. They're like, they use RF to talk to one another and Wi-Fi, and then they like drive depending on the data that they find, and they drive together as a team.
Oh, they okay.
It's a little
team of robots.
It is.
Do they get catapulted together?
They do.
I'm just picturing like 5 little voices like screaming as they're catapulting onto the surface. That's really cool. Are there different scales? I'm sure the answer is yes, but how do you categorize the size of a rover? Like, are there cube rovers? Are there micro rovers, mini? Like, what's the language around rovers?
So that's a great question. Rovers are really unique. So we have a rover here called Cube Rover, and we've been developing it in-house for like 14 years. We've won so many different contracts on it. I think 11 specifically, worth $20 million. So this is a very highly developed rover. And I was talking to one of our engineers on it today, Andrea, and I was asking about the sizes. So I was like, what is a mini rover? Is there a extra large? And she was like, no, they come in sizes based on U. So a U stands for unit, and it's used in satellites as well. So 1 U equals 1,000 centimeters cubed in terms of volume. Then our rovers come in different sizes of that. So like a 2U, which would be our smallest, up to I think like a 6 or an 8U. So you can get a lot bigger of a rover that carries a lot more mass.
Sure.
The idea of the U was actually us to incorporate that into the rover. No one had ever done that before. It had been used in satellites, but never in rovers. So we were the first to incorporate those two together to kind of unify the interfaces that we have in space. We were talking earlier about how there are so many different interfaces, and right now nothing is standard. And I think that's just another example of how we're standardizing space.
Yeah, I think the way you're building a process, not only for yourselves, but in order for people to access the moon is just so critical and so interesting. It's a business model that's equivalent to like Western Union or something. Like it's as transformative in that context.
Right, and just so accessible. It's honestly, getting to work at this company is such an honor because it is nice to see how everybody can touch space now and touch the moon, where before it was so difficult to do. I mean, even working at NASA, right, you can get pigeonholed into a million different things and never actually end up working on a space program necessarily. But here, everything that we do goes into space, goes to the moon, and everyone that we interact with, so all of our customers, all of our vendors, everything that they touch goes to space too. It's just so much more accessible. Yeah. And it's financially accessible too.
Right. Yeah, it's not the domain of governments or large private organizations anymore.
Right. Yeah, you don't have to know somebody to know somebody to know somebody. You just go to our website.
That's awesome.
Yeah.
In the clean room, we talked a little bit about the historical significance of this Mission One. We talked about how this is the first U.S. launch to land on the moon since probably 73, right around there, nearly 50 years. Why this company? Why this mission? You know, we started with this, but tell us more about it.
So why this company is where I'm going to start. The passion of the people here, unlike anything I've ever seen, ever. And I know they talk about that. There's a lot of passion in any kind of startup. But here you have a bunch of space nerds who are really passionate space nerds and haven't had an opportunity necessarily to work in space before. So it's really exciting. And it's fun. It's an environment of just innovation and curiosity and a lot of people who really love doing a hard thing and are really excited about it every day. So we also talked about how working in space where we are right now, it's not a super simple job, right? Every day is not the same. It's not monotonous by any means. You always have a different challenge, but at a certain point, it's not a job anymore. It's just fun, and you're working a problem with your friends who are all really passionate about the same thing. I think looking into why Astrobotic, why Pittsburgh, why right now, there's so many different parts to that. So Pittsburgh, we're reinventing ourselves. We really are kind of a technology hub right now. And we're really lucky that we get to develop here with all of these different people and all of these different technology companies because we're learning from one another. So I think that's why Pittsburgh. When you're talking about why the moon, why go back after 50 years? Why aren't we looking elsewhere? So there's this really cool opportunity for refueling at the moon. So the moon is really far away. I think it's 239,000 miles. So really far out there, but close enough, right?
Close
enough. But getting out of Earth's atmosphere and its gravitational pull takes a ton of fuel. So it really limits us as to where we can go. But if you build a refueling station on the moon from some of the lunar ice that's available there, so you can use that as a fueling source and build up a fueling station quite literally right there. You can refuel at the moon and then go even further than we've ever been able to go before. It just makes it more technologically feasible to continue to explore our solar system and even beyond.
And it's cheaper to launch from the moon too because 1/6 gravity, right?
Exactly.
Awesome.
Yeah, it's way cheaper to launch from the moon. It's easier to refuel. It just makes sense, honestly, to build something there. And why now? Now we finally have the technology to be able to do that with additional computer systems, being able to talk to each other more back and forth. We're not quite as limited as we were in the 60s and 70s.
Got it. My niece asked me, do you name the rovers like you would name a dog or a pet or something like that?
Yes and no, right? So Cube Rover is Cube Rover. Call it Cube Rover. Same with the payloads. They kind of come with their own names, but they do get named at a certain point, right? So my favorite is Pitmas. Pitmas, yeah. So it stands for Peregrine Ion Trap Mass Spectrometer. So very long name. But those names, I don't know, they kind of become a thing. So they aren't only representative of the payload, they're representative of the team. And on our payload team, what we love to do is to make little puns with them. So we have a ton of different names. Pitmas is one, Let's is another. Let's. Let's is easy. So we'll say little puns like, let's get excited for Pitmas, like Christmas.
I like that.
Little things like that. So they really become pets, friends. A whole entity.
Anthropomorphized.
Absolutely, yeah.
That's very cool. So with Mission 1 and Mission 2, these are sort of foundational missions. But I assume that the longer term strategy for access to the moon is more comprehensive. There's more to it, right?
Oh yeah, absolutely. So building infrastructure for power and honestly building an entire just moon base is a great way to put it. where you can power up because we have landers, we have rovers. So with a lander, right, you can bring supplies if you need to bring supplies. Rovers, you can drive between different sites or drive to the power source itself, recharge up. And different companies or even different countries could use our own power grid, essentially, to power themselves up on the moon. So they don't have to provide that for themselves, and it's actually cheaper and more efficient for them.
Right. So you're essentially, I mean, you could act as almost like an equipment provider for anyone who wanted to send other equipment or humans even.
Yeah, exactly. That's what we're poised to do. Yeah. And that's why we're starting with landers and rovers themselves. So that way we can start to kind of build out that infrastructure on the moon. Yeah, and then build that for the next generation to come in.
It's almost like infrastructure as a service, but for the moon.
Yeah, exactly. It's building the foundation blocks. Yeah. And that's what Astrobotic has poised ourselves really well to do. I mean, we have always been so focused on the moon and making that accessible to everyone. And this is just the next step of Astrobotic, making it even more accessible.
I hope that phrase accessible to everyone is just what everyone takes away from this. You know, that's what they should remember, that now they have access through these missions. When they never did before in their lives.
Exactly.
You can tell that to somebody who's, 75 or somebody who's 5, and it should affect them the same way.
And it does, right? That's what we're seeing. I'll point to Moonbox, who's one of our customers with DHL. So Moonbox is essentially like a time capsule. You can send anything that you want in it. I think prices start at like $400, right? So it's relatively accessible to everybody. Yeah. And we get kids sending in, little mementos that are really important to them. Everything to mementos from astronauts from the Apollo missions themselves, right? Who were on the actual moon and want to send something back. So it is something, just everybody is so excited, no matter what age you are, no matter what stage of life you are. It is this really collective, exciting thing that we're doing.
Right.
Yeah.
I have one more question for you, and I think it's a little deeper one. How thin is the line between historical technological achievement and cautionary tale? So that line between success and failure, essentially, how thin is that line? And how do you shift that in your favor?
Yeah, so there is I'm going to say a tightrope between success and failure, right? So we're part of the CLPS program. They have essentially a goal of, we want to go back to the moon. That's what we have to do. We know that's our next step, that we have to go back there and then continue building that out to go further into space. That's NASA's goal. So we want to be successful, of course, being part of that program. In commercial space, it's a very different world because you don't have a certain set of regulations that you have to follow necessarily. Certainly there are things that, of course, you're paying attention to and making sure that you're safe.
Sure. And you're working with the FFA on launch and the FCC on radio control and all these things.
Absolutely. Yeah. Sure. So we work with the FFA. Well, we work with the FAA and the FCC regularly.
Right.
But there's a lot of other things to it, right? So in every single subsystem that we have, there's a certain level of risk. And it's what level of risk are you willing to accept in order to make sure that your spacecraft is successful? Or if there is a major risk that you have to take in order to get to launch, or because, a certain item that you thought you needed isn't available, how can we work around that? How can we engineer around that problem? Like, it is constantly a tightrope back and forth between, okay, success and, okay, today it looks a little more potentially like failure. Today it looks a lot more like success. And our goal is to always be looking a lot more like success, but space is hard. Like, it is the hardest thing that I will be lucky enough to do in my life, right? So every day it's just about pushing that needle a little bit further to make sure that we do get to the moon and that we deliver all of these fantastic stories that we've heard, right, from all of our payloads and every single vendor that has put in time and effort into helping us design and build our spacecraft. Push that a little bit further towards success. And if we don't make it, right, worst case scenario, we don't make it, a lot of tears, a lot of broken hearts and dreams. But we learned a lot. Like, these past 10 years that we've been working on this, it's not for nothing. And if anybody says that it is, I mean, come talk to me. Like, I'll prove to you that it's not.
They're wrong, yeah.
Yeah.
We've talked a lot about Mission 1, we've talked a lot about Mission 2, but I think As far as this company is concerned, those are foundational, but just the beginning. You know, it's the long term of access to the moon and that's where you guys are focused.
Exactly.
In your risk calculations and your benefit calculations, in how you learn and how you even accept failure. It's learning for mission 3, 4, 5, 6, and 7.
Yeah, I mean, every day we're learning, and no matter what we learn on mission 1, so let's say mission 1 is not successful.
Yeah.
That does not mean mission 2 will not be.
Right, absolutely.
Yeah,
Constant
you just
learning process.
learn. Yeah, you learn with every single step that you take, you learn something new. And you know, it's funny, most of the time when I'm when I'm talking to different people that we get to work with, you know, they're always like, if they've done it before, they're like, you're learning and you're figuring it out and you're doing great things and something new that you've never gotten to do before. We're really excited for you. And we'll continue to do that for every single mission that we progress through.
That's awesome. Well, thank you. So not only will we have, you know, Florida as it's known and Texas as it's known, but now we have California with SpaceX and we have Pittsburgh, Pennsylvania with more space robotics. It's awesome. I'm envious. I want it in Michigan.
Yeah.
But
maybe we'll expand.
Yeah, you guys are fairly close too. It's not too long of a drive.
Yeah.
You just have to get through Ohio, which I think we can agree on neither state likes, right?
No, yeah, absolutely. Ohio's the worst.
Ohio's the worst.